Now that we've learned about elements and how the electrons circle around the nucleus of every element, let's talk about what happens when two elements come together or they form a bond. So a couple of quick terms. A molecule is any elements that are bonded together. So a molecule could be, for example, two of the same element bonded together, like O2, this is oxygen, or it could be a mix of elements like H2O, which is water. Now, a compound is basically the same thing as a molecule, only it has to have two different elements in it. So water is a molecule, and it's also a compound because it has hydrogen and oxygen. Whereas oxygen, O2, is not a compound because it only has oxygen, so it's just a molecule. I don't know who came up with these rules. They're kind of weird. Now, there's three main types of chemical bonds. There's ionic, covalent, and hydrogen bonds. Hydrogen bonds are by far the weakest. They're extremely weak bonds. Ionic bonds are also pretty weak. And as you'll see, covalent bonds are the strongest bonds. So let's talk first about ionic bonds. So let's look here at our periodic table. Let's look at sodium. Sodium is Na. You can see sodium's atomic number is 11, which means it has 11 protons, neutrons, and electrons. So take a minute, pause this video, and draw the sodium atom for me on a piece of paper. Okay, so draw sodium now. Okay, so hopefully you drew sodium, and if you still are practicing, it's okay. So sodium should look something like this, and you can see sodium has 11 electrons, like I said. So that means the first shell has 1, 2, and then you have to go into a second shell, which remember can hold up to 8. So our second shell has 1, 2, 3, 4, 5, 6, 7, 8. So now we're up to 10, but sodium has 11 electrons. So we had to make a third shell, and that third shell has this one sad, lonely little electron. So now what I want you to do is pause the video again, and this time you're going to do it really fast, and you're going to do it like so good, and you're going to draw a chlorine here that has an atomic number of 17. Okay, so pause the video now and hurry up and draw chlorine and see how you do. Okay, so if you drew your chlorine correctly, it should look something like this, okay? It should have 2 electrons, 1, 2 on the first shell, and then the second shell will have 8, so that brings you to 10, and then your third shell will have 7, so that brings you to 17, which is chlorine's atomic number. Notice something really interesting here. Chlorine needs 1 more electron right here in order to have what we call a stable octet. Stable octet meaning that full valence shell. And remember, it's every atom's goal in life to get that full valence shell. That's all it wants. So chlorine right now is really, really sad. It's crying. It wants that extra electron. Conveniently, sodium has 1 electron in its outer shell. It does not want that electron. It's also sad. It's crying. Okay, it wants to get rid of it. So what can these guys do? It's really simple. Sodium can simply give away its single electron to chlorine. And when that happens, then both sodium and chlorine will be extremely happy, and they will both have that stable octet. If sodium gives its electron away to chlorine, then sodium is losing the electron. Remember, electrons have a negative charge, so sodium is losing a negative charge, so it will become a sodium cation. A cation is any ion, an element that has a positive charge, whereas chlorine is going to be picking up that extra electron, so it'll have a negative charge. It becomes what we call an anion. So an anion is an ion with a negative charge. When these two form this bond where sodium gives its electron to chlorine, its friend, this will create the compound sodium chloride, NaCl, also known as table salt. So congratulations, you have just created salt by simply drawing this bond. That's what salt is. All right, so what you need to know about ionic bonds, such as sodium chloride. Number one, ionic bonds are relatively weak. What this means is if you had something like sodium chloride, it would be really easy to break this bond. As you know, if you put sodium chloride salt into water, it will dissolve, right? Like if you're making pasta and you're boiling the water, you put salt in there, it's going to dissolve. So sugar is the same way. So ionic bonds are pretty easy to break. The other thing you want to know about ionic bonds is that the electrons are being given away or taken. So remember from this picture, sodium is giving away its electron and chlorine is taking it. So the electrons are being given and taken, and that these bonds are pretty weak and easy to break. Now let's talk about another example. This time, I want you to draw for me first carbon molecule, okay, my favorite one. So draw carbon now. Okay, so if you've drawn carbon, you know carbon has 6 electrons, 2 in its first shell and 4 in its second. So tell me, is carbon happy right now? The answer is no. Carbon is sad. It's crying. And it's sad because it doesn't have that full stable octet. Carbon needs 4 more electrons in order to have that full outer valence shell. So what can carbon do? Well, along comes carbon's friend, hydrogen. All right, so I'm going to draw hydrogen over here. Hydrogen has 1 lonely little electron on it. So how many more electrons does hydrogen want? Well, I'll tell you. Hydrogen wants 1 more electron because remember, the first shell only holds 2 in order to be full. So hydrogen has 1 electron here. It only wants 1 more in order to be happy. So what can hydrogen and carbon do? Well, maybe hydrogen can share this electron with its friend, carbon. Okay, so they're going to share. Now, this hydrogen is really happy because it has the 2 electrons it always wanted. Carbon is still not happy because it still needs 3 more. So what we can do is have 3 more hydrogens come in. All of these hydrogens have 1 electron as per usual. And what can happen is these hydrogens can share their electrons with carbon. So now what we ended up with is 4 really happy hydrogens and 1 really happy carbon because now carbon has that full 8 electrons that it always wanted. What we've just created is we had 1 carbon and 4 hydrogens. We've created CH4. This is methane gas. It's an explosive gas, all right? So you've just created methane, guys. That's not great. Anyway, so here's something interesting. Remember when we were talking about sodium chloride before, and I told you that sodium is going to give an electron to chlorine? But this time, when we created methane, nobody's giving any electrons away. Instead, they're sharing. These guys are friendly and they're like sharing electrons instead of giving and taking electrons. So this is a totally different type of bond. This bond is what's called a covalent bond. So it's really important to be able to distinguish between an ionic bond and a covalent bond. So what you should remember, ionic bonds are relatively weak, which means we can easily break them, whereas covalent bonds are like super strong. You cannot break covalent bonds without an enzyme. You would need some sort of enzyme in order to break them. In an ionic bond, the electrons were given away and taken by a different molecule, whereas in a covalent bond, electrons are shared. And finally, some examples of ionic bonds, as we talked about, are salts like sodium chloride. Some examples of covalent bonds are methane, like we just drew, water, oxygen, carbon dioxide. Okay, they're all sharing the electrons. Imagine how hard it would be to break apart oxygen. Like, that'd be impossible. Okay, so that's the differences between ionic and covalent bonds. Now, in class on Tuesday, we're going to practice drawing some more of these bonds. So if you want to get a head start, try drawing in your notebook water, oxygen, and carbon dioxide. While you're at it, also try drawing nitrogen, N2, nitrogen gas. That one is a tricky one. Also try drawing some salts. Try drawing magnesium fluoride. All right, that one's a tricky one. So try practicing these and we'll see how you do in class. Now, the last thing to mention in terms of ionic and covalent bonds. Now, we've been drawing them like this with the electrons being shown, but in real life, it would take us forever if we had to draw everything like this. So how we usually will draw it is we'll use the molecular formula, like I showed you before, like hydrogen would be H2. This little 2 down here means there's 2 hydrogens that are being bonded together. Sometimes chemists might even use what's called a structural formula, and it will look like this: a hydrogen bonded to another hydrogen. When you see this single line right here, this means there's a single bond. Sometimes you might see a double line. So for example, oxygen, O2, actually it's 2 oxygens that are double bonded to one another. So this would be a double bond. And sometimes, such as nitrogen, you will see it's a triple bond. So practice drawing these. Actually, on the following slides, I think that it will actually show you a lot of the answers. So if you need to cheat, go ahead. And here is a nice YouTube video that shows you what ionic and covalent bonds look like from a good visual standpoint if you're a visual learner. And of course, some review questions on the PowerPoint